Operation Desert Storm demonstrated high-tempo combined arms warfare conducted across open desert terrain. Success relied on the integrated employment of armored, mechanized, artillery, and support vehicles rather than individual platforms. Extended distances and sustained maneuver imposed significant logistical and maintenance demands, shaping a vehicle inventory optimized for standoff engagement, rapid breaching, and continuous operational momentum. The M1A1 Abrams served as the primary breakthrough element for armored brigades, institutionalizing the air-land battle doctrine. The system utilized its 120mm smoothbore cannon to establish firepower overmatch, enabling the destruction of enemy armored targets at ranges exceeding 2,500 meters. Operational data confirmed that the Chobham armor package provided superior protection against Soviet-era kinetic energy penetrators. However, the extreme fuel consumption of the gas turbine engine placed a significant strain on the tactical fuel distribution network. This reliance on a continuous petroleum supply chain remained the primary operational constraint during high-tempo trans-desert maneuvers. The M2A2 Bradley functioned as the primary mechanized infantry platform, designed to maintain pace with the M1A1 Abrams while providing suppression of anti-tank guided missile teams. The system utilized its integrated TOW missile launcher to engage heavy armor at distances up to 3,750 meters, effectively functioning as a secondary tank destroyer during desert maneuvers. While the vehicle demonstrated high lethality and internal volume for dismounted squads, its aluminum alloy hull required supplemental steel armor plating to meet survivability requirements against 30mm autocannon fire. The platform solidified the doctrine of integrated fire and movement, though its maintenance requirements challenged forward-deployed repair units. The M113A3 functioned as a high-mobility utility and support platform, providing protected transport for specialized units within armored formations. The system utilized its amphibious-capable tracked chassis to maintain a maximum road speed of 66 kilometers per hour, ensuring logistical and medical elements could keep pace with frontline M1A1 and M2 Bradley maneuvers. Despite its ubiquitous presence, the platform's aluminum armor was insufficient against modern anti-tank munitions, necessitating its transition from a primary frontline combatant to a specialized support role. Its modular design remained critical for command, casualty evacuation, and mortar transport, though its tactical employment was strictly limited to secondary echelons to minimize attrition. The M109 series functioned as the primary mobile, indirect fire support system for heavy divisions, providing organic, long-range artillery coverage during rapid advances. The system utilized its 155mm cannon to deliver sustained fire support at ranges up to 24,000 meters using standard projectiles, ensuring that maneuvering armored units remained under a protective fire umbrella. While the platform demonstrated high tactical mobility across desert terrain, its manual loading operations in older variants limited the rate of fire compared to emerging automated systems. The integration of the A6 Paladin variant during the conflict significantly reduced the time from movement to fire mission, aligning with the requirement for rapid, responsive suppression of Iraqi defensive lines. The M270 MLRS functioned as a high-volume saturation system designed to neutralize enemy air defenses and counter battery assets at the divisional level. The system utilized its ability to ripple-fire 12 rockets to a maximum range of 32,000 meters, delivering thousands of submunitions over a target area in less than 60 seconds. This capability, referred to as steel rain, was instrumental in the systematic suppression of Iraqi artillery and logistics hubs prior to ground maneuvers. While highly effective in theater-wide operations, the platform's heavy logistical footprint for ammunition resupply necessitated dedicated transport corridors and specialized handling equipment, reflecting the high resource cost of maintaining massed indirect fire superiority. The AAVP-7A1 functioned as the primary mechanized transport for the U.S. Marine Corps, facilitating the transition of combat power from ship to shore and across inland desert terrain. The system utilized its troop-carrying capacity to transport 25 combat-equipped Marines, providing significantly higher organic mass than Army counterparts. During the ground phase, its role shifted from amphibious landing to serving as a mobile platform for clearing minefields and breaching obstacles. However, the vehicle's large silhouette and relatively thin armor plating presented a high-risk profile in modern anti-tank environments. Its effectiveness was primarily measured by its ability to sustain Marine infantry momentum during the rapid envelopment of Iraqi forces in Kuwait. The WWII functioned as the primary reconnaissance and security platform for Marine light armored infantry battalions, providing rapid screening and flanking capabilities. The system utilized its M2 42 25mm Bushmaster chain gun to neutralize light armor and infantry positions while maintaining a maximum swimming speed of 10 km per hour for riverine crossings. Its high operational mobility allowed it to act as the eyes and ears of the division, identifying gaps in Iraqi defensive lines before the arrival of heavier formations. While its speed was superior to tracked counterparts, its wheeled configuration faced limitations in extremely soft sand, and its light armor offered no protection against dedicated anti-tank weaponry, necessitating a doctrine of hit-and-run engagement. The M1A1 functioned as the primary heavy recovery system, essential for maintaining the operational readiness of the M1A1 Abrams fleet. The system utilized its 56-ton winching capacity to extract mired or disabled tanks from combat zones, preventing the abandonment of high-value assets during rapid advances. Its role was strictly logistical and maintenance-oriented, providing the necessary mechanical leverage to perform field-level engine swaps and heavy lifting. Despite its critical role, the M1A1 struggled to keep pace with the faster turbine-driven Abrams units and lacked the engine power to tow a fully combat-loaded M1A1 on steep gradients, a shortfall that dictated the pacing of recovery operations and highlighted a gap in the heavy-lift logistics chain. The M60A1A VLB functioned as a mobile gap crossing system, enabling armored formations to bypass anti-tank ditches and man-made obstacles during breaching operations. The system utilized a 18-meter scissor-type steel bridge, capable of being deployed in under 10 minutes to support vehicles weighing up to 60 tons. In operational practice, the platform was a critical enabler for maintaining offensive tempo through fortified Iraqi defensive lines in Kuwait. However, its reliance on the legacy M60 tank chassis resulted in significant difficulty maintaining pace with modern M1A1 Abrams units, and its limited self-defense capabilities required continuous escort by primary combat elements. The M728 CEV functioned as the primary heavy obstacle clearing platform, designed to neutralize fortified positions and man-made barriers during the breaching phase. The system utilized its short-barreled 165mm demolition gun to deliver high-explosive squash-head HESH rounds for the destruction of bunkers and concrete obstacles at close range. Its integrated A-frame crane and front-mounted dozer blade were essential for clearing paths through Iraqi sand berms and anti-tank ditches. While effective in its specialized role, the platform's reliance on the aging M60 chassis resulted in mobility disparities compared to modern M1A1 Abrams formations. The slow rate of fire and limited range of the demolition gun necessitated that the vehicle operate under the direct protection of primary combat tanks to mitigate its high vulnerability during engineering operations. The M3 Bradley CFV functioned as the primary armored reconnaissance platform for armored cavalry regiments, tasked with intelligence gathering and flank security. The system utilized an internal configuration adjusted to carry significantly more 25mm ammunition and TIAW missiles than the infantry variant, allowing for sustained engagement during long-range scouting missions. Its thermal imaging capabilities proved decisive in detecting Iraqi armored units through sandstorms and absolute darkness. However, the lack of dismountable infantry space meant the platform relied entirely on its organic firepower for self-defense when ambushed, requiring close integration with scout helicopters to compensate for ground-level observational constraints. The M163 VADS functioned as a point defense anti-aircraft system, designed to provide low-altitude protection for forward-deployed ground units. The system utilized a modified 20mm M61 Vulcan rotary cannon to deliver a high rate of fire against low-flying rotary wing assets and ground-level targets. During Operation Desert Storm, its roles shifted primarily to ground support and convoy security due to the rapid achievement of coalition air supremacy. While highly effective at suppressing infantry and light vehicles with a cyclic rate of 3,000 rounds per minute, its lack of advanced radar tracking and short effective range limited its utility against modern high-speed fixed-wing aircraft. The platform's reliance on the M113 chassis ensured logistical commonality, but highlighted the need for more sophisticated, missile-based air defense integration. The M578 functioned as a light-duty recovery and maintenance asset, specifically designed to support self-propelled artillery units and light armored formations. The system utilized its crane-equipped rotating turret to perform engine swaps and lift heavy components on the battlefield, facilitating rapid field repairs for vehicles like the M109 howitzer and the M110. Its relatively high speed and tracked configuration allowed it to maneuver across desert sands more effectively than wheeled service vehicles. However, with a limited winch capacity compared to the M88, it was incapable of recovering main battle tanks, restricting its operational utility to supporting the second line of the armored advance. The M110A2 functioned as the heaviest caliber artillery piece in the U.S. inventory, providing long-range, high-explosive destruction of reinforced Iraqi fortifications and command centers. The system utilized its massive 203mm barrel to deliver 200-pound projectiles at ranges exceeding 22,000 meters, or 30,000 meters, with rocket-assisted projectiles. Its role was primarily focused on general support and heavy bombardment, where its immense lethality compensated for its slow rate of fire. Due to its open-top design, the crew lacked protection from chemical agents and counter-battery fire, a significant tactical limitation that eventually led to its replacement by the more versatile and protected MLRS and M109 systems following the conflict. The M113 functioned as the ubiquitous utility platform, providing protected mobility for infantry, medical teams, and command elements across the theater of operations. The system utilized its lightweight aluminum hull to maintain a high power-to-weight ratio, ensuring it could navigate soft sand and keep pace with mechanized formations. While its primary role was battlefield taxiing, its thin armor profile proved insufficient against heavy machine guns and anti-tank mines, restricting its use to secondary lines once the main armored breach was established. The platform's versatility across multiple variants made it the logistical foundation of the ground campaign, though its lack of offensive firepower required constant integration with Bradley or Abrams units.